Alright, so in this problem, I have 4 to the power of 1 plus x plus 4 to the power of 1 minus x is equal to 10. So to start, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, I have 4 to the power of 1 plus x. So that's going to equal 4 to the power of 1 times 4 to the power of x, plus I have 4 to the power of 1 times 4 to the power of negative x is equal to 10. Now I'm going to factor out 4 to the power of 1. Actually, before that, 4 to the power of negative x, that's the same thing as 1 over 4 to the power of x, and 4 times 1 over 4 to the power of x is going to be 4 over 4 to the power of x. So now, I'm going to let 4 to the power of x equal to the variable y. So now I have 4y plus 4 over y is equal to 10. And now, to solve this, I'm going to multiply both sides by y, so I get 4y squared plus 4 is equal to 10y, meaning 4y squared minus 10y plus 4 is equal to 0. And this means that 2y squared minus 5y plus 2 is equal to 0. And you have to use the quadratic formula to solve this. So you get negative 5, so positive 5, plus or minus the square root of b squared, so negative 5 squared, which is 25, minus 4 times a, which is 2, times c, which is 2, all over 2a. And this is equal to 5 plus or minus the square root of 25 minus 16, which is 9, over 4, which is equal to 5 plus or minus 3 over 4, which is equal to either 8 over 4 or 2 over 4. Now 8 over 4 is 2, and 2 over 4 is 1/2. So I have y equals 2 and y equals 1/2. Now remember how we let 4 to the power of x equal to y. So I first have 4 to the power of x is equal to 2, and if 4 to the power of x equals 2, then this means that x is equal to 1/2. Now I have 4 to the power of x is equal to 1/2, and this means that x is equal to negative 1/2. Alright, so in this problem, I have 2 to the power of x is equal to 5 to the power of x plus 2. So to solve this, I'm going to first start by using the property of exponents that states that a to the power of m plus n, this is the same thing as a to the power of m times a to the power of n. So in this case, we have 5 to the power of x plus 2, and we can think of a as 5, m as x, and n as 2. So we want to put this in this form right here. So to do that, well, a is 5, so we have 5 to the power of m, which is x, times 5 to the power of n, which is 2. So now we have 2 to the power of x is equal to 5 to the power of x times 5 to the power of 2. And now 5 to the power of 2, we all know that's 25. So now I have 2 to the power of x is equal to 5 to the power of x times 25. Now, we want both of these x's to be together. So to do that, I'm going to have to move 5 to the power of x to my left-hand side. And to do that, I have to divide both sides by 5 to the power of x. So then these two cancel out, and I get 2 to the power of x over 5 to the power of x is equal to 25. Now, if I have something in the form a to the power of m over a to the power of n, if I have something in the form a to the power of m over b to the power of m, this is the same thing as a over b to the power of m. So 2 to the power of x over 5 to the power of x, that's going to equal 2 over 5 to the power of x, which is equal to 25. Now from here, if we want to solve for the value of x, we're going to have to make it a real variable instead of an exponent. And to do that, I'm going to take the log on both sides. So I have log 2 over 5 to the power of x is equal to log 25. And the reason I did this is because I can use the property that states that if I have something in form log a to the power of b, I can move this exponent b to the front. So it's going to equal b times log a. So in this case, I have x times log 2 over 5 is equal to log 25, meaning x is equal to log 25 over log 2 over 5. Alright, so in this problem, I have 5 to the power of x is equal to 10. So obviously, I want to find the value of x here, seeing that as that's the only variable, so I want to find the value of x. So for my solution, I'm going to first start by rewriting my equation. So my equation is 5 to the power of x is equal to 10. And to start, you can already tell that x is going to be some number between 1 and 2. Because if you plug in x as 1, you get 5. And if you get x as 2, you get 25. And this means that x is going to be a decimal and not a whole number. So to start off, what I'm going to do is I'm going to take the log on both sides. So I have log 5 to the power of x is equal to log 10. And the reason I did this is because if I have something in the form log a to the power of b, I can move this exponent b to the front, and this is going to equal b times log a. So in this case, I have log 5 to the power of x, and we can think of a as 5 and b as x. So I can move b, or x in this case, to the front of the logarithm. And this is going to equal x times log 5 is equal to log 10. So now I want to simplify this. So log 10, I'm going to simplify to log of 2 times 5, because 10 is equal to 2 times 5. And now if I have something in the form log a times b, this is equal to log a plus log b. So log 2 times 5, that's going to equal log 2 plus log 5. And now if I divide both sides by log 5, these two cancel out, and I get x is equal to log 2 plus log 5 over log 5. And this simplifies to 1 plus log 2 over log 5.